So I asked you year 12 to use your pipe cleaners. So what's a pipe cleaner? It's one single strip. And I wanted you to, mine doesn't look like a rectangle, yours are much better. And I wanted you to create the largest rectangle you can make. Harry, was that in terms of area or perimeter? Perimeter. So the single piece of pipe cleaner, the largest perimeter? Well, we want the largest, well, they're all the same perimeter, right? So we want the largest area that we can create. I've got 3 examples from people. We win. Out of these 2, which one looks like it has a bigger area? Oh, we got another contender. So, what about out of these 2? Which one looks bigger? Is this one a rectangle?
Square.
Yeah, exactly. This is that.
Interesting.
It's actually a rhombus.
Have a think about it. Is this a rectangle? Okay, so this is your starter into the topic of what we call optimization. In your textbook, it's called the applications of maximum and minimum. And I jokingly said that this is probably the hardest part of the calculus topic. And then I gave you a worksheet that asks you to find the area of rectangles, or the perimeter of rectangles. So what's going on there? The reason why this is the hardest part of the application of calculus, so I need you guys watching all up the front now. It is actually probably the hardest because it relates to using algebra to represent worded situations. So kind of like solving word problems. And I remember back in year 10 when I had you guys that I had a lot of trouble trying to convey this to you all. So I want to have another crack at it, okay? So here's the idea behind optimization. Have you guys seen this word before, optimization? Yeah, where have you seen it, Angus?
Sorry, yesterday.
Where?
IPT.
Oh no, what does it mean in IPT?
To optimize the system.
Okay, so when you use a word and use it to define it in the same word, that's always a bit tricky, isn't it? More efficient. Yeah, great, I love it. Actually, when I was updating Origin the other day, they were like saying, oh yeah, the update is making this more optimized, right? So, and they were like, essentially it's just making it better. Yeah, okay. So we're gonna think about making it better. Let's be more specific. When I'm optimizing something in a work context, right? Let's think about a company. A company often wants to maximize profits. Yeah, you write this down with me. Our company often wants to maximize profits. What's other things that a company wants to do? Maybe they want to, let's say they're producing something. Yeah, so they want to optimize the reduction.
Is that what you said? Redox?
Or maybe, or what do companies want to do? Like, oh, we want to maximize profits. Maybe they want to minimize. They want to minimize profit as well. What would they want to minimize, do you reckon? Expenditures, yeah, expenditure. Hot topic these days, maybe CO2 emissions. Maybe we need to, now if you're thinking about packaging, right? We want to maybe, if I'm like a Coca-Cola company, I want to maximize.
Plastic waste.
We definitely want to maximize plastic waste. We want to maximize, if I think about making bottles or something, right? I want to maximize the amount of stuff I can hold for the material that I'm given, right? So you might want to maximize the volume for a given product. Yep. Maximize the volume for a given product. And similarly, if you are a fence company and you're given a particular amount of fencing, everyone here has the same amount, yeah? What we'd want to do with this, you would want to maximize the area that you can have in this, right? Why would we want to do that? Well, if you're making a paddock or something, you want to have as much space as you can have inside the paddock given a particular amount of fencing. That's the idea behind this, okay? The hard part about optimization is not the concept behind it, like, yeah, making things better, maximizing, minimizing. It's actually thinking about how does this relate to mathematics, yeah? So if we think about these terms, maximizing and minimizing, where have we seen these line before? Maximizing and minimizing in this calculus topic. What have you been doing? Like the,
I was thinking of it, but I didn't know.
yeah. Yeah, no, just go for it. There's no wrong answer here, right? So think about your functions. Like you looked at finding global maximums, global minimums, yeah? And when I said that we need to find the y value, that's relating to a particular amount. It should be a one value. And that's exactly what we're going to do here.